Welcome to another video from explainingcomputers.com. A few videos back I looked at the ROCKPro64 from Pine64, which is a single board computer with a x4 PCIe expansion slot. Now, seeing such a slot on a single board computer was very interesting, but it becomes really exciting when we can actually plug something into that slot and see how it works. And so for this video, Pine64 have supplied me with this rather crinkly packet which contains a SATA adapter. So let's go and fit this to the ROCKPro64 and see how it performs. So here we have the ROCKPro64 with its x4 PCIe slot and the SATA card we're going to fit, which I hope you can see in its white bag on my white background. Anyway, let's get the computer out of the way a second and get into the bag. I think this should be a fairly easy unpackaging, even for me. There we are, all crinkle, crinkle, out it comes. Oh, an anti-static bag as well. Open this thing up, there we are, and here is our card. Let's just put it down like that so you can see it in a bit more detail. And I should tell you that technically this is the ROCKPro64 PCIe to dual SATA 2 interface card, which lets us know that it's got a SATA 2 interface, not a SATA 3, but that's still not too bad. And it costs, in case you're wondering, $9.99 from the Pine64 website. And I should point out we've got either use of here two internal SATA ports, as you can see there, or if we look on the back of the card, we've got two eSATA ports. So I'm sure you've got a choice here of using either both the internal ports, both the external ports, or one of one and one of the other. Now, in addition to this card, Pine64 have also sent me another white envelope which contains a cable. If we look inside here, this is a power cable, and this enables, if I can get through here, this enables us to power up two drives from the ROCKPro64. So we've got the card, we've got the cable, and we've got the computer here, so these could all plug together. So in theory all we've got to do is to plug in the card. It goes in like this, I think. There we are, and that's nice and straightforward. And the cable, if I just unfoil that, where's the adapter for power? I think it is down here. There's a cable thing there. This will plug in down there, I think. There we are, and there we are. In theory this is all now set up to access and power two SATA drives. Now, this of course is not an ideal setup for using it. They do actually sell a case which is called the ROCKPro64 Metal Desktop NAS casing, which you can use to contain the board and this card and a couple of drives, a couple of 3.5-inch drives, or I'm sure 2.5-inch drives if you wish. But I don't have that case. I don't need it just for testing. So what I'm going to do is to take all this and to put it into a sort of self-constructed plastic card bracket. So it'll look something like this to keep everything securely in place. Now, you may be wondering what I'm going to connect, and for testing purposes it's going to be these, which are a couple of Kingston SSDs, and specifically these are Kingston A400 120GB SSDs, which I've come across fairly recently. Look, nice little metal boxes. I like these SSDs because of well, the price really. These cost £21 in Amazon Co UK, or about $28 on Amazon.com in late October 2018. So they're a very good drive for all kinds of purposes, not least for our testing purposes here. So let's get these things connected up into our system. And by the magic of filmmaking, here we are all connected up and raring to go. And if you're wondering why I'm using SSDs in this test and not connecting to, say, a couple of 3.5-inch hard drives, the answer is that there are two different power supplies available for the ROCKPro64. And the one I've got is this one. And this is the 3-amp 12-volt power supply for the ROCKPro64, and this is perfectly sufficient to power the board, and it'll power a couple of SSDs as well, I'm sure, but it won't power, say, a couple of 3.5-inch hard drives as well. It might power maybe one 2.5-inch drive on top. I'm not going to risk it, that's why I'm using SSDs. But I would point out there is also a 5-amp power supply available for the ROCKPro64, and that would power the board and a couple of 3.5-inch drives. Anyway, everything is now all connected up and raring to go, so let's see how the SATA card performs. Well, here I am back again in, as you can see, a Ubuntu console. And since I spoke to you last, I've been trying out lots of different ROCKPro64 distro images to see which ones support the PCIe SATA card. And what I found that, at least right now, which is late October 2018, there isn't a distro that supports the SATA card but also comes with a graphical desktop. Now, given that many people will want to use the ROCKPro64 with a SATA card to build a small server or a NAS or something like that, this is not a problem. And indeed it is possible to control an OpenMediaVault NAS using its web interface, as we'll see in a few minutes. But for now I'm going to stick with running this console-only version of Ubuntu, and it does provide me with an opportunity to show you how to mount and test drives using a Linux command line interface. And of course, what I'm going to show you here doesn't just apply to a ROCKPro64 with a SATA card, it applies to any Linux distribution in which you want to mount and test drives using the command line. So the first thing we need to do is just to check what hardware is available to us, and to do that I'll use the command list block devices, which is abbreviated to lsblk. If I type that in, you will see there we've got all the drives and partitions which are available here and potentially mounted, and right at the top of the screen you'll see that SDA and SDB, those are our two Kingston SSDs. We've got a good clue about that because you can see the capacity is about right, 111.8 gigabytes formatted, and you'll see SDA is the actual physical hardware, beneath it SDA1 is the one partition on that drive. But as you can see, they're not mounted, and to do that what we need to do is to create a mount point for the drive. And a mount point is basically a directory, a folder, sitting in the folder, either MMT for mount or media. So what I need to do is to create those folders, and then we can attach them to the drives by mounting them, and the thing will work. So I need to do this using the super user privileges, so I'll type sudo on the start of my commands here, and I need to do a mkdir, make directory, in MMT. I'm going to call the first one I think SATA 1. I could call it anything I like, but SATA 1 is obviously logical. We'll do that. I have to ask my password. ROCK64 is the default password here, and that seems to have worked. And now I need to do the same thing again, and I'll create another directory called SATA 2. There we are. And I need to mount the drives. So if I do a sudo again, I'll type mount, and the first device we have is a SDA1. That's the partition we want to mount up. So we'll use dev, it's in devs, and it's a SDA1, and we're going to attach that to the mount point, which is going to be mount and SATA 1. That seems to have worked, and then again we'll come back and it's going to be SDB1 is the other SSD, and we'll attach that to SATA 2. And then if we're really lucky, we'll just press the up arrow, get back to that, write the code. Where was it? We've got lists there, and press that. And yes, you can now see we've got those two drives and they are mounted. Now, I would mention here, if you're mounting a drive that's been set up in Windows, and these two SSDs had been set up in Windows, they could well have the NTFS file system on them. And by default, this isn't supported, at least in this version of Ubuntu on the ROCKPro64. It might not be in other Linux distros by default. So I've had to use this command here, apt-get install NTFS -3G. That installs support for the NTFS file system on this system. I had to do that before I was showing you the thing I'm doing here. So if you're ever having problems mounting drives created in Windows on Linux, do try that command before you do your mounts. Now, I suppose we should just prove this all works, so I'll go change directory to mount SATA 1, and we could do a list, ls, and oh look, there we are, look, we've got some things there which seems to suggest things are working, and of course we should probably try going to SATA 2 as well. Don't think anything's on that one. There we are, but you can see that things are working okay. Now, and I want to test the drives, and I've got to find a way of doing that in a console interface, and I've learnt about something called HD parameters, which again I've installed using sudo apt-get install HD parameters, abbreviated to HDPARM, and with this installed I can do some tests. So I can do this, I can do sudo and HDPARM -t, and it's going to be dev SDA. Oops, SDA, if I can get it right, SDA1. And if I run that, it should start to run a test of obviously the first of the drives, and it's going to give us some data. And there we are, in theory that's running at 315.53 megabytes a second. I'm not absolutely certain I believe that. In fact, I don't believe that, because the maximum speed of a SATA 2 interface that we're using here is 300 megabytes a second. So that has to be affected by caching. And indeed, this test, to give you the actual text of it, displays the speed of reading through the buffer cache of a disk without any prior caching of data. But it's going through the buffer cache. But we can actually get around that. We can go back in here and put in a direct like that. And that should give us a proper test where we're bypassing the page cache. That I think I'm going to believe a little bit more. Oh, it's exciting, isn't it? The tension in the console is killing us. Yes, 244 megabytes a second. I can believe that's actually happening on this system. Shall we just do the other one as well, just to be wild? SD B1, what does that give us? Oh, again, what's going to happen? It's having a think. Diddle-diddle-dee, we're sitting here watching a console, 266. And of course, this data you'd probably have to run several times to get it accurate. Let's do it again on that one, because it's going to go up and down a bit. But this does suggest we're getting reasonable performance. We're getting good real-world performance here. The drives here are SATA 3, so they clearly aren't on the constraint here. We're reading from them. But it suggests we are getting a good 250, 260 megabytes a second over the SATA interface on the PCIe card connected to the ROCKPro64. Now, I'm sure some of you are thinking, what if we connected one of these SSDs to the ROCKPro64 using a USB 3 to SATA interface? And that's a very good question, and be a good comparison to know. So I think I'll now type a shutdown now to take us out of the system, close things down neatly, and we'll execute that. I'll set things up again, and we'll test out SATA versus USB 3. So, here I am back again, and as you can see, I've reconfigured the hardware, so one of the SSDs is still connected via the SATA port on the PCIe card, but the other SSD is now connected via this USB 3 to SATA adapter. So let's go back to the console, and as you can see, I've already mounted up both of the drives. I've created a new mount point called USB 3 for the USB 3 drive. That seemed a good idea. And I'm all now set up to run some tests. So again, I've got the tester thing set up for HD parameters here to initially run an SDA1, which is the SATA connected drive. So let's run that. Let that run through. And that should be roughly as we got before, sort of 250, 260 megabytes a second, 258. Let's run it twice to have a really good solid test. And what's it going to do? Yes, oh, it got a little bit higher. Let's do it 3 times. So a really, really good set of tests. And then we can think about a rough average. So this is our definitive test of the SATA speed. There it's somewhere between 255, 265, getting towards 260 megabytes a second. Let's do it now for the SDB1, which is connected via the USB 3 interface. Will it be much different? It might not be, of course, because it just depends how things are implemented. We're nowhere near the speed of drives. Of course, this is purely an interface test. 259, so very, very similar. Let's run that one again. 259, what we're going to get could be higher, could be lower. It's like a game show, isn't it? Oh, that's remarkably consistent. Final test of that, and then we've got 3 on each one, and I think we've come to a definitive result. So let's do that. And 263, always gone up a little bit. But I think the main thing we've shown there, really, you've got absolutely no difference, whether you're connected via the SATA 2 connection on the PCIe card or the USB 3 to SATA adapter. So what do we conclude from this? Well, I conclude if you want to connect just one drive to a ROCKPro64, you might as well use a USB 3 to SATA adapter, unless of course you've got other things you want to do with that, a USB 3 port. But if you want to connect 2 drives, it's well worth thinking about using that PCIe to SATA card. And of course that also gives you the flexibility of doing things like connecting eSATA devices. Right, here I am back again. I've now got the ROCKPro64 set up with OpenMediaVault, which is running fine. It's accessing the SATA drives. At least it's accessing one SATA drive because I've got the other one connected to the Latte Panda Alpha here, which I want to use to do a little bit of testing and show you how that's all working. And if we go to the desktop of a Latte Panda Alpha, I thought it was nice to have one single board computer talking to another one in a second. I've just initially done a test using Crystal Diskmark of the SSD we were using for the speed test, so that's why the other drive's connected to this machine. And I've only run the first test once because this drive's been hammered enough today. But as you can see, read and write is at over 400 megabytes a second. I just wanted to show you that to make it clear that the speed tests we were doing earlier were not being compromised by the drive. They were real tests of the interface on the ROCKPro64. So anyway, we've got that going on, and I've now also got OpenMediaVault access panel here for getting into it on the ROCKPro64 to show that's all working well. I would say it is a very, very responsive version of OpenMediaVault we have running on the ROCKPro64, I guess because it's quite a powerful machine. And if we go down here, we can see in disks, clearly we've got the, in the second there we are, the Kingston drive there is sitting there being connected up, and in file systems it's hopefully also connects up. There it is, King 120AA, etc. And I've got that in a share, of course, so we can actually get to it. It's in a shared folder, which is sitting there. And on this machine, as you can imagine, I've got the shared folder over there. Look, it's mapped as network drive. There we are, ROCKPro SATA, etc. And I think it's got a picture in it of, oh look, from the video last week of the lovely DF robot, Raspberry Pi control robot thing going around in the park. Anyway, if you want to know how OpenMediaVault works, you can always look in my video about setting it up on a ROCK64. Same principle applies here. And I thought what it might be nice to do is to finish off by just seeing what the performance is, which will of course be limited not by the speed of the drives on the ROCKPro64, but by the gigabit Ethernet it's connected to. But we go back to Crystal Disk Mark. What if we just to pick up that drive? I haven't tried this. This is a pure test. Let's see what we can do. We'll do the first one and just see what kind of results we get. This will be fascinating, seeing what we get testing out our network drive, which is an SSD connected to the PCIe card, the ROCKPro64, says here, hoping this thing will get on and do its thing. So we'll let this run through. And there we are, we've achieved what, 103 megabytes a second read, 41 write. Bit low on the write, but certainly for the read, that's exactly what you would expect over gigabit Ethernet. So I think we've now well and truly tested out as much as we can the drives connected to the ROCKPro64 by the PCIe card. Well, there we are. For the first time I fitted an expansion card, a PCIe expansion card no less, to a single board computer. And yes, I'm sure some of you are already typing away in the comments, that means, Chris, it's no longer a single board computer, and that has to be true. More broadly, the other thing that interests me though is beyond what we've been doing to a single board computer or not single board computer, is we've fitted an expansion card here, a PCIe expansion card, to an ARM-based computer. And in the world today, the ARM-based computers we have all around us are things like tablets and smartphones and single-board computers, which we haven't been putting in expansion cards like PCIe cards as we've done in this video. And so what we've been looking at in this video today may be an interesting point in evolution in our application of computers with ARM processors. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.